Okay, here are the two options for formaldehyde's Lewis structure that you were given. You were given a skeletal structure, but this is with everything in it. So what we're going to do is for each of the elements, we're going to do that method of figuring out their formal charge. So for hydrogen, it brings in one valence electron. It has 0 electrons that are lone pairs on it, and it has one bond, and so it's going to have a formal charge of 0. So 0. For this carbon, it brings in 4 valence electrons. It has 2 electrons that are not bonded, and it has 3 bonds, giving it a total of a -1 formal charge. This oxygen came in with 6 valence electrons. It has 2 electrons that are part of their lone pairs, and it's forming 3 bonds, and so it has a +1 here, and so its formal charge is +1. This hydrogen brought in 1 electron. It has 0 I keep saying valence electrons for lone pairs. It has 0 lone pairs on it, and it forms 1 bond, and so it has a formal charge of 0. I'm going to repeat that process for this option. So this hydrogen came with 1 valence electron. It has 0 lone pairs. It forms 1 bond. So this one oxygen has 0 for its formal charge. This hydrogen is going to be the same. It has brought in 1. It has no lone pairs. It forms 1 bond. It has a formal charge of 0. The carbon had 4 valence electrons it brought in. It has 0 lone pairs on it, and it forms 4 bonds, so it has a formal charge of 0. The oxygen brought in 6 valence electrons. It has 4 electrons in its lone pairs, and it forms 2 bonds, and it also has a formal charge of 0. So between these two Lewis structures, remember the one that has no formal charges is preferred, so that means this structure is the preferred structure. All right, so now that we've seen that once, let's look at our 2 options for CO2 that we had from our previous examples. So on this example, this oxygen right here brought in 6 valence electrons. It has 2 electrons from the lone pairs, and it forms 3 bonds, and it's going to have a formal charge of +1. The carbon brought in 4 valence electrons. It has 0 lone pairs, and it forms 4 bonds, so it has a formal charge of 0. This oxygen brought in 6 valence electrons. It has 6 electrons from the lone pairs, and it has 1 bond, so that's going to give it a -1 for its formal charge. Over here, this oxygen brought in 6 valence electrons. It not equals yet. It has 4 electrons from the lone pairs, and it forms 2 bonds, so giving it a formal charge of 0. Carbon had 4 valence electrons. It has 0 lone pairs, and it forms 4 bonds, so it has a formal charge of 0. This oxygen right here brought in 6 valence electrons. It has 4 electrons in its lone pairs, and it formed 2 bonds, so it has a formal charge of 0. So just looking at the formal charges, we know that this is the preferred Lewis structure for carbon dioxide. And that's so if you ever are drawing a Lewis structure and aren't sure which one to do, especially forming those double and triple bonds, what you need to do is look at both options and determine the formal charges to help you figure out which one will be preferred.